Well, we're here today to accomplish a couple things. This is a brand new 8-inch combination gold diamond dredge. And the main reason we're sitting in one of my friend's pools is because we had to do a lot of testing on flotation, the power of the engine, and so on. The reason we're playing with this smaller diesel engine today is because it's extremely small, light, and powerful package. For a little 40 horsepower diesel, it's probably about 150 some odd pounds less than most other small diesel engines. Had to add the additional flotation to the dredge to accommodate the engine. The engine weighs around 500 pounds or so, but it's still, again, several hundred pounds lighter than most of the other diesel engines in its horsepower range. What I'm going to do here next, I'm going to show you how to prime the pump. I'm going to show you how to start the engine and how to run some of the basic components on the machine. You can see the engine has a nice little simple throttle control on it. It's got a kind of a Murphy panel, an auto shutdown panel. It gives you low oil, overheat, temperatures, and sensors, and so on. But it's a pretty nice little slick package so far. The dredge has a 10-gallon fuel tank on it. So we're estimating we'll probably burn between a gallon and a gallon and a quarter per hour for estimated fuel consumption. I'm going to go ahead and first I'm going to prime the pump. We're going to have the garden hose. Normally to prime the pump, what you're going to do is you're going to take like a 5-gallon bucket. You're going to pour a 5-gallon bucket down the throat here, okay, until this basically overflows. Once it overflows, you put your cap back on, you start it. If you have a garden hose, you're going to skip that step. So basically, I'm going to flood the foot valve. Okay, I'm starting to hear water pour out the discharge of the pump, so I know I'm primed. Put my cap back on. Okay, now to start the engine, you go low throttle. We're going to turn it to the center position, and basically that initiates the glow plugs, so we can start the engine. And you let it put it in that position, I don't know, 30, 60 seconds or so. There's a light here that tells you. And I can hear it click. Oh, I just heard it click. Okay, now we're green. There it goes. And now I can start the engine. So I can see we're primed. Get into a full-blown operation, I want to explain some of the basic plumbing on the machine. Okay. The first thing is, the most important thing is we just kind of went through quickly was the priming. Now, when I'm talking about priming, I am just talking about having this entire system here flooded with water up to this point here. That means the pump is completely filled with water before you start the engine. And if you don't pre-prime the pump, what's going to happen if you're running the pump dry. And if you run this pump without water for more than a couple minutes, there's a chance that you can shorten the life of your pump seal. It is a replaceable part out in the field, but you don't want to have to mess with it if you don't have to. So always make a habit of having the entire system flooded with water before you ever start your engine. Okay? Let me talk about some of the pressure hose plumbing here real quick. We are coming off the pump with a 4-inch pressure hose discharge. Okay. Over at this end over here, we have a 4-inch by 3-inch by 3-inch splitter. So what we're doing is we're coming out with 2 heavy-duty pieces of 3-inch pressure hose coming down underneath the deck that I'm standing on right here, and they're going into the power jet. And if you want to off here, we have what's called another Y splitter. And what this splitter accomplishes is it allows you to pull full pressure and full velocity off the pump. And we use this pressure hose for a variety of different applications. We're talking again about this hose right here. The pressure hose is used to power a smaller 2.5-inch, 3-inch suction nozzle that I'll show you in a few minutes, okay? And that's used for sucking up the ripples while the dredge is in operation. One of the big problems in the operation is to do a cleanup or to shut the system, to remove all the concentrates from the rip boards can take, sometimes a half-hour. With the use of a combination of this pressure hose and a smaller 2.5-inch or 3-inch dredge, you're able to vacuum the ripples while the dredge is running. This means you don't have to stop the machine every 6 hours to do a cleanup. You just clean it up whenever the ripples are showing signs of floating. In a diamond mining application, we may be evacuating the last 2 sections of the sluice box every 6 hours, or anywhere from 1 hour to 6 hours. In diamond type material, it's more important to clean it more frequently. Okay, I'm going to go through some of the basics on how the dredge works, first of all. Okay, once again, before you ever start the engine, you have to have the pump completely fill the water up to this level. Otherwise, you shouldn't be running the engine. Otherwise, you're going to eventually do some damage on the pump seals. So always run the pump in a wet condition. This is your pump intake. On the end of this, there is a foot valve or a check valve, a one-way valve on the bottom. So when you shut the engine off, you should be able to maintain a prime. So once you prime it that one time by basically removing this, fill it with water with a bucket of water until it overflows, put your cap back on, and then you can start your engine. So what happens is the pump just pumps clean water. So you're pulling in clean water through the pump intake, out of the pump, and the pump is producing somewhere around maybe 1,000 gallons a minute at about, let's say, 40, 50 psi. So you're really getting a lot of power out of it. So the high pressure water comes through here, it comes through a 4-inch pressure hose. It comes into an aluminum, a very clean Y splitter. You can see this right here, okay? This maintains good velocity in the line. And you have 2 3-inch pressure hoses assemblies, okay? And the 2 3-inch pressure hoses go down and they come back and they both tie into the power jet directly below me. I'm going to go ahead and remove the deck here so you can see how the plumbing is on the power jet. Now you can see how you have your 2 3-inch pressure hoses that come into the power jet. And these are called jet logs, okay? So each jet log is injecting around 400 to 500 gallons a minute into the log and into the jet. So you have a combination of water flow between the 2 logs entering somewhere between 800 and 1,000 gallons a minute going into the power jet. Then that means on your suction hose, this is your suction hose here, is going to pull about a 1-to-1 ratio. So if we inject, let's say, 1,000 gallons a minute in here, we're going to be pulling close to 1,000 gallons a minute into your suction hose. You'll see here, this is a kind of like a clamshell that wraps around the suction hose. So you basically just slide your suction hose in, and when you get it in there, you basically just take these levers here and push this down here, and it locks the suction hose in place. And you have an adjustment here if you want to make it lighter, a little tighter clamp or a looser clamp. It will depend on what kind of suction hose you're running. Some hoses have a slightly larger OD or a slightly smaller OD, and this gives you adjustments. You can accommodate a variety of different suction hoses. Now you notice on this jet, it's not quite like any of our typical power jets that we manufacture. You're going to see some big, heavy steel metal plates on here. We call it an Africanized jet. This thing is designed to last season after season in some really harsh terrain. So basically, you've got the material come through the suction hose, traveling through the power jet, into your jet flare, and then what happens, everything hits, this is called an Alaskan damper or rubber damper, okay? The material comes across this heavy weight. In fact, you can tell it's almost like 3/8 of an inch thick. And what it does, it knocks down the surface tension of the water. So if you have a lot of bubbles or you have any gold that's in flotation, this will help knock it down. It also helps disperse the energy. What we have first coming into the sluice box here is we have a primary recovery riffle. Okay, this is a relatively large, tall, deep riffle. This primary riffle will recover pretty much all the coarse gold, the majority of all the visible gold, and even some of the fine gold. But this section here, we get tempted to clean it out, if we can, at least twice a day, because the majority of the value is going to be right here. The next section of the sluice box, we have a heavy-duty woven wire classifier screen, which basically covers up a double sluice layer. Okay, so on the very bottom layer of the sluice box, you have carpet, you have a riffle, you have carpet, a riffle, and then you have a metal plate on top, or an aluminum plate up on top. Then another layer of carpet, and then another riffle, and then you got the wire mesh. Okay, but basically all the 1/2 inch minus material goes into the lower sluice box, and all that 1/2 inch minus material is being washed through roughly about a 6 to 7 foot long sluice box. So you're getting absolutely perfect fine flour gold recovery. The simple, short 8-foot box traditionally has been one of the finest fine gold recovery sluices in the world.